Let's review a little bit of information that we already know about exponents before we look at a power of a power. So when we're multiplying 2 to the third times 2 to the fifth, we add the exponents and it becomes 2 to the 3 plus 5, which is 2 to the eighth. To explain that, let's take a look at x squared times x to the third. What we have here is x squared, which is x, times x to the third, which is x times x times x. And this here is the expanded form for x to the fifth. And what we did was we added the exponents. Now something very different happens when we look at a power raised to another power. If you think about this, 2 to the third, if we were calling that a set, 2 to the third would be appearing 2 times because I'm squaring it, so it's 2 to the third times 2 to the third. Using the information that we just had from practicing multiplying exponents, we would add these exponents, so we would have 3 plus 3 is 6. Well, the power rule for raising a power to a power is to actually multiply these two. So you have 2 to the sixth because it's 2 times 3. Let's take a look at a couple of examples. So in this first example over here, what we have is base is 3, and then we have this would be 4 times 3, or 12. This is actually 3 to the fourth times 3 to the fourth times 3 to the fourth. And this could actually be calculated. We're not going to do that now. And x to the fifth raised to the third power, we would just simply multiply the exponents. And in this last example, we have a base of -4 raised to the power of 6. And again, like the first example here, this one can actually be calculated. Now, this one seems to be easier than it really is. When I have 2x to the third power, what this really is 2 to the third power times x to the third power. And since 2 to the third power is 8, we just bring down the x to the third power. And this is having a 1 here for each of these two exponents. So when I raise the power to the power, the exponent rule still applies, but each one of the items that's inside the parentheses, the coefficient and the variable, will each be raised to the power of 3. Let's take a look at a few more examples of those because they do get more complicated. In this example, I'm going to do this in expanded form also, but first we'll do this quickly. So 3 is going to be squared times x, which is going to be squared, times y, which is going to be squared. And if I wrote this out, meaning 3xy times 3xy, I actually multiplied them. I have 3 times 3 is 9. I have number times number, letter times letter, and there's another letter times letter. So x times x is x squared, and y times y is y squared. Now this over here, I didn't fully answer. This 3 squared is 9, x squared, y squared. We get the same answer, but seeing it in expanded form, we're actually multiply one full term times the other. If this was a 3 here, there would be 3 sets of 3xy. So in this problem, we have parentheses around the -3, and that's raised to the second power. And you can have brackets or another set of parentheses where that's raised again to the fourth power. And essentially what we're going to have is -3. This is a 1 here, so -3, 1 times 2 times 4 is to the 8th power. And this can actually be calculated, but we'll leave it in that form. We'll take a step backward for a second and we'll just look at 2/3. We want to work with fractions that have exponents of powers raised to powers, but first we'll do this one here. This is the same as 2/3 times 2/3, so the answer should be 4/9. And writing it this way, each thing that's inside is going to get squared. So what I have is 4/9. I want to expand on this problem and show how multiplication of powers works. Then we'll do one where it's powers raised to powers. So here, what I've added is I'm multiplying by 2/3 to the 6th power. So this base of 2/3 is then raised to the 2 plus 6 because I'm multiplying. This is not a power raised to a power yet. And 2 plus 6 is 8. Now, that's the same as 2 to the 8th divided by 3 to the 8th. This can actually be calculated. We'll leave it at this stage because I want to just show how the rules for the exponents work. And let's add one more layer to this. So all I've done here is I've taken the original 2/3 to 2nd power and I've raised it, putting a 3. So this is now power raised to a power. So it's the same as 2/3 squared times 2/3 squared times 2/3 squared. If we did it this way, each one that you multiply, you would be adding the exponents and you would get 2/3 to the 6th power. But just looking at this over here, I can just write it as 2/3 to the 2 times 3 or 6th power, and it just gives you an immediate answer. In this example, nothing changes because it's a negative, but we would have minus 3/4 raised to the 20th power. This problem has several different layers, and one thing that I want to talk about is the negative when you're raising to a power. So first, each one of these has to be treated as if it's minus 3/4 to the 3rd power and times p to the 3rd power. So this piece over here can't be further simplified, but this can. So 3 to the 3rd power is 27, and 4 to the 3rd power is 64. And I'm just going to bring down the times p to the 3rd power. Now, what I do want to talk about is the negative. So if I have a negative times a negative, I get a positive. If I then multiply by a negative, I get a negative. So this was an even exponent. This one was odd. And the next one, each time that I multiply by a negative, it's going to keep flipping. And what we see is whenever the exponent is an even number, then the answer is going to be positive. And every time that the exponent is an odd number, in this case, it would be a negative times a negative times a negative. And what we have here, a negative times a negative is a positive times a negative. Every time you have an odd exponent, the answer would be negative. So just so that you're aware, this was actually one of the questions that appeared on one of the SAT tests, entrance exam for college. So if the entrance exam for the SAT or ACT asks you to find the answer when you have an odd exponent, that you're not going to actually multiply this by itself 103 times. They're just looking to see if you understand that since the exponent is odd, then the answer must be also odd.